Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class we're going to be doing an Arduino temperature alert project. Now in the past we have done very simple temperature alert projects. Basically we have taken an analog temperature sensor and depending on what temperature it read, either it turned on a red LED, a yellow LED, a green LED, or a blue LED, and that was about it. Today we are going to be doing a bit more complicated project. So we're going to be adding a couple of different modules. We're going to be adding an LCD screen, and we're going to be putting this all together into a single project, and we're going to have the Arduino reading values from different modules and then doing things with those values and printing the results out on an I2C LCD screen. So if you take a look at this thing that we're going to be building today, basically this is what we're going to be looking at. So we have an Arduino here. So we have the Arduino Uno that we normally use. We have a DHT11. This is a temperature humidity sensor. This right here is a real-time clock. So this tells us what the time and date is. And then we're going to be printing out information onto the I2C 20x4 LCD screen. So looking at it here, this probably looks a little bit complicated. Let's go over to the workbench. I will show you what this project actually does, show you how it's built, and then we'll go take a look at the code. Okay, so here is our project all put together. You know, there are some people out there, they say, Eli, do you ever want to go back to the server room? You know, do you just want to be doing educational classes for the rest of your career? And I really do have to say yes. And the answer is this right here. Because you see, what I can do, I can make something that functionally works, and then when I'm done, I just sweep it off my desk and go on to the next thing, right? I don't have to worry about assembling this into something that users are actually going to be interacting with. Because obviously, again, everything here works perfectly fine. This technically works, but oh my golly, it is ugly. I would not want to release this onto a user in the real world. But anyways, one of the important things I want you to see here is that this is a completely self-contained project. So this is not connected to a computer. There's no processing coming from anything else. I have this little Arduino plugged into a little USB battery pack. So this can be plugged directly into a wall. This can be plugged into a battery pack, so on and so forth. So for this project, again, we've got the Arduino Uno. So this is just a standard Arduino Uno here. We have the real-time clock module. So this is our little real-time clock. So this actually gives us the time even when the power goes out. So it tells us what the date, the time, so on and so forth is. And then here we have our DHT11. This is our temperature humidity sensor. So this is a digital temperature humidity sensor. It's a bit more accurate than the analog temperature sensor, and it also gives you that humidity value. So at the end of the day, when we assemble this whole little project here, basically this is the readout that we get. And the interesting thing is that we're pulling information from both the real-time clock module and the temperature sensor, and then we're doing some processing with that. So basically what we're saying now is, imagine somebody walks into a room and so they can see, okay, it's showing that it's Friday, it's the 15th of May 2020. So that is the current date as I'm doing this. Then down here we see what the time is. It's 10:04 and 52 seconds, right? So we can make sure all of that's accurate. Then past that we go down and we see what the current readings are. So the current temperature reading in Fahrenheit, to be clear, this is Fahrenheit for this, is 68.18 degrees right now, and the humidity value is at 58%. Now the important thing, the curious thing, and this is where we do some processing with this Arduino project, is we have this little alert down here. So what this alert does is this alert tells us the highest temperature we have gotten to since this project has been restarted and what time it hit that number. So I just restarted this thing a little bit ago. When I did, I put my hand on the temperature sensor to get it above 83 degrees. So it got up to 83.48 degrees. And we can see that it got up to 83.48 degrees at 9:52. So it's currently 10:05. So basically what happens here with this alert, there's an if-else statement, or there's basically an if statement. The if statement says if the temperature goes above 80 degrees Fahrenheit, Then start tracking the time and the temperature. When it gets to the highest point, then basically set the temperature and the time for when it hit to the highest point, and then print it out here. So imagine if you're putting a sensor system like this into something like a server room or some kind of place where you care about the temperature, right? Not only do you want to know that the temperature went above a certain value, that it went above 80 degrees, but you'd also like to know how warm it got and also know when that happened. So if I walk into the server room and I see the server room got to, let's say, 90 degrees, and it got to 90 degrees at 10 o'clock in the morning, and I know that there was a power outage at 10 o'clock in the morning, then I can go, oh, okay, that makes sense. I'm just going to reset this and everything should be fine. On the other hand, if I come in the morning, I see this alert on, I see this got up to 90 degrees at 1 o'clock in the morning, I didn't think there was a power outage, I didn't think there was a problem, then I might decide, okay, I need to research this, figure out what's going on. There may be some kind of issue where, let's say, my air conditioning unit is icing up at night. Maybe in the environment that I'm in, it's very humid at night, so the air conditioning machine is icing up at night, therefore it's not functioning properly at, let's say, 1 or 2 o'clock in the morning. The temperature in the server room goes up, and then I need to try to figure out what that problem is. So basically that's what this is doing, is once the temperature gets above 80 degrees, it logs the max temperature and the time it hits that max temperature, and it prints it out here. Now the thing is, if I clear this, so I'm just going to press the little reset button here. When I press the reset button, it's then going to clear that alert. So it'll take a second. So again, we can see Friday, we can see that it's the 15th of May, we can see the time, we can see the current temperature and humidity, and you'll notice there's no alert down here. So since the temperature has not gone above that 80 degree threshold, there's no alert down here at all. And so again, that's just one of those things I put in there. It's a little bit of it's a very simple code, but it's the type of thing that I want you to think about. I don't really care the max temperature if it gets to 79 degrees. As long as it's below 80 degrees, I really don't want to know about it, because that's something to remember whenever you create user interfaces, even for yourself, is to have things stick out, right? So if this is always telling me the max temperature, it's very easy for me just to ignore it, right? Oh yeah, it's a max temperature, I'm sure it's fine, I'm not even worried about it, right? By having something pop up new and say alert here, that shows me, oh wait a minute, the max temperature might be above something that I think it should be. So anyways, so that's what's there. And again, if I hold on to the temperature sensor, so this is the DHT11 sensor, we can see that the temperature is slowly going up. Again, do remember with the DHT temperature sensors, they are slower than the analog temperature sensor. So with the analog temperature sensor, as soon as you touch it, the temperature starts going up. Because of the digital processing, it is a little bit slower. It's a little bit of lag. I mean, no big deal. In the real world, it doesn't matter. In the real world, it doesn't matter. but for these little projects, like it's waiting a little bit, right? Okay, so there we go. We hit above 80 degrees. I can let go. So we can see that the alert, and what you can see now is the temperature is still rising. Again, with a DHT11, it takes a while. There's a bit of a lag as it goes up and down. So as this is rising, the alert keeps changing. It keeps going up. So every time this goes up, the timestamp keeps continuing to go up, and it will continue to go up until the temperature hits its max level. Then the temperature will start going down again, and then the alert will remain where it's at. So again, we can see that the alert is just remaining where it's at. And then hopefully in a second, once the temperature starts to cool down on the sensor, okay, so now it's down to 83.84. So the actual temperature is going down, but we can see the alert has stayed at 84.2, and we can see that it was hit at 9 minutes after 10, 27 seconds, and we can see that's in the past now. So that's how this project actually works. As far as putting it all together, it's relatively simple. Let me just unplug the little battery here so it's a little easier to take a look at. So the big thing here is you are going to need a little breadboard in order to split out the power. All of these devices, so the I2C screen, the real-time clock, and the DHT11, they do require the 5-volt power supply. So you're going to need to split off your 5 volts. So 5-volt power is going to go to each one of these devices. Now this is the I2C, so an I2C screen basically uses the I2C protocol. We are plugging this, the I2C screen, into the SCL and the SDA on the Arduino board. So the Arduino board has the SCL and the SDA, at least the newest, the version 3 does. They have that directly on the board, and so we're plugging into that. So that's the power and the ground, 5 volt for power, ground, and then the SDA and the SCL. The thing is then is with the real-time clock. So I showed you how to use the real-time clock library in the past, and so you can plug to the SCL and the SDA using the real-time clock. But since we're currently using the SDL and the SCA for the I2C screen, you're also able to modify in the code what digital pins that this connects to. So what I've done is I've modified in the code, and SCL then goes to digital pin 7 and SDA goes to digital pin 6 on the Arduino. So that's just one thing to keep in mind there. Then past that, again, the DHT11 digital sensor, there's not much to it. You need 5 volt going to it. You need it connected to ground. And then basically for the sensor wire for this, I'm simply connecting that to digital pin 2. And so that's how all of this is set up. Really, the only thing where you might get a little bit confused about is, again, with the SDL and the SCA on both the real-time clock and the screen. Basically for this project, the screen gets the SCL and SDA ports on the Arduino, and then the real-time clock, I'm mapping those to ports 6 and 7 on the Arduino. That should be the only place that you might get confused if you've been following along with my other projects. So with that, let's go over and take a look at the code to see how this works. So here's the code on my demonstration machine. So basically with this project today, when we're taking a look at the code, what I've done is I've cannibalized a number of different projects. So I have shown you folks how to use the DHT11 sensor in the past. So basically we're using the Adafruit DHT11 library that I used in the previous classes, and that's here. Then as far as the real-time clock, so for me, I find that rinky-dink. It's literally called the rinky-dink. Anyways, there's a rinky-dink DS3231 library. I showed you how to do that in a previous class. Again, it does not give you all the functionality of the real-time clock, but for a project like this, it works absolutely fine, and it's easy to use. Again, one of the things with the real-time clock, anytime you deal with a real-time clock, I swear to you, I don't know what they're doing with those libraries. They're shockingly difficult to use sometimes. So I'm using the rinky-dink library for this that I showed you in a previous class. Then past that, for the I2C screen, we're using the wire library that's built in. We're then using the LCD library and the liquid crystal I2C library that we have used for many projects at this time. Past that, we're then going to go down and we're going to configure the DHT11 sensor. So we're going to define the DHT pin is going to be to digital pin 2. We are going to define the DHT type to be DHT11. And then for the DHT to actually start it, we're going to feed DHT, the DHT pin, and the DHT type. So basically I copied and pasted this out of the standard Adafruit example code here. I removed a lot of the extraneous stuff in that particular code. And so this is all that's required to actually make the sensor fire and work. Past that, we're then going to go down to that I2C liquid crystal display screen. So liquid crystal underscore I2C, we are going to create a resource called LCD. So when we interact with the screen, it's going to be called LCD. We then need to feed it the I2C address. So the address for this particular screen, the default is 0x27. So this should work for you. If you're using a standard I2C 20x4 LCD screen, this should work for you. If not, use the I2C scanner. So there's a sketch called the I2C scanner that will scan to tell you what your address is. Again, it is important to understand in the I2C world, the I2C is an addressable scheme. So basically it's looking for something at this address. It's like an IP address. If you plug in the wrong address and something's not there, it won't be discovered. So this is the only place where you may have an issue with that I2C LCD screen. Then the rest of this is the configurations for that particular screen. Then we're going to come down and we're going to configure the real-time clock. Again, for the DS3231, we are going to call it RTC for real-time clock. We are going to connect, I think it's the SDA to 6 and the SCL to pin 7. So you just simply say 6 and 7 there, and away you go. Then we're going to come down here. The final thing for setting up the overall environment is we're going to come up with the temperature variables. So we're going to be interacting with these variables throughout the sketch, and so we have to create global variables so that we can actually interact with them. So we're going to create a float max temp equals 80. So basically what I'm going to say is the max temperature, simply the alert temperature, is 80. I am simply setting it to float here because if it's float, then you can plug in 80.90 if you want. You could plug in, a decimal point. So remember, an int is a whole number, a float is a decimal number. I simply put float here. So again, if you're really worried about it, you're like, no, I'm only worried if it's 80.5 degrees, then you could plug it in here. That's why I use a float. Technically, if I'm just using 80, if I'm simply using whole numbers, I could use an int. Then we're going to create an int for alert. So this is what we're going to test against. So basically, if it goes above this particular temperature, we're going to say the alert value is 1. If the alert value is 1, then print out the alert on the LCD screen. I'll show you that later, but basically this is basically used for testing purposes. Then we're going to create a float for the alert temp. So this is that temperature that we're going to be printing out. When the temperature gets above a certain amount, it'll be whatever that temperature is. Then we're going to create a string for alert time to make my life easier for the time. I'm just making it a string, and again, that will get printed out. Then we're going to come down and actually set up everything. So we go into the void setup, and the first thing that we're going to do is we're going to start the LCD screen. So LCD begins. It's a 20 by 4 screen. So this means 20 columns by 4 rows. LCD set backlight pin. So we're setting that to 3, and we're going to set that to positive. So basically what this is doing is setting the backlight to be on. Now you did not see that when I showed you the example. The reason being is because if I actually have the backlight on the camera, it's very difficult to look at the screen. So normally the backlight would be on. I just actually pulled the little jumper pin to turn it off. LCD.set backlight, and so it's basically setting the backlight to high. So this is where we're setting the backlight on. Then we're going to come down. We're going to start the temperature sensor. So start temperature sensor, DHT.begin. So that starts the temperature sensor. Then we're going to come down here and we're going to start clock. So RTC, we're also going to begin that. The final bit of code down here is if for some reason your real-time clock has not already been set, you can uncomment these lines of code to actually set your clock. So you could set it to whatever day it is, you could set it to whatever time it is, and you can set it to whatever date it is. Do remember though, again, when you're using the real-time clock, if you set the time and date this way, remember to come back immediately, comment everything back out again, and re-upload the code. Remember, anything that you have in the setup loop, this will run every single time you turn the Arduino on. So a problem you can have with the clock is if you don't re-upload this with everything commented back out, every time you reboot your Arduino, it will reset itself to whatever you have set here. So remember, uncomment, modify as need be, upload. As soon as it's uploaded and you've made sure that it's actually stuck, comment back in and then upload again. Basically, you need to make sure these lines of code are commented out because every time the Arduino restarts, basically it will reset itself to whatever time you set here if these lines of code have not been commented out. Then past that, we're going to go down and actually take a look at the code itself, and it's all pretty simple. I mean, most of the reason this looks complex is just in order to use the LCD screen, you've got to do a lot of things like set what the cursor is, print something else, reset what the cursor is, whole 9 yards. But it's actually pretty simple. It's just a little bit tedious to write out. So the first thing that we're going to do is we're going to delay for 2 seconds. So one of the things with a DHT11 sensor is especially when you turn it on, it takes a second to calibrate itself. So we don't want to get any kind of erroneous readings, especially in that alert display. So basically what we're doing is we're going to delay in the beginning of the loop. So a lot of times whenever you're dealing with loops in the Arduino world, at some point you'll set up the delay. Most of the time I actually set up the delay at the end of the loop, basically have it run through the loop and then wait 2 seconds and then run through the loop again. With this, I'm putting the delay in the beginning because again, it takes a second for that DHT11 to initially calibrate. I don't want any erroneous readings right in the beginning. So I'm delaying for 2 seconds in the beginning. Then basically here, again in the comment, if the temp is above max temp, we're going to set the alert temp and the timestamp to a certain value. So what we're going to do here is DHT, so this is the temperature sensor. If the read temperature true, so basically what this is this is the Fahrenheit. This is the Fahrenheit. So if you want the Celsius temperature, you do that. If you want the Fahrenheit temperature, you put true in there. Don't ask me why they did the library that way. They just did. So if you want the Fahrenheit, you put true in there. So basically, if DHT read temperature is true, so whatever the Fahrenheit temperature is greater than the max temperature, the first thing that we're going to do is we're going to set the value for that alert variable to equal 1. The reason that we're doing that is down here, to print out that alert on the screen, we're going to say if alert equals 1. So while the alert doesn't equal 1, so basically, until the temperature goes above the max temp, alert is going to stay at 0, and so none of this will print out. No alert will get printed out. But as soon as the temperature value is tripped, as soon as the temperature reading goes above whatever we have for max temp, currently for us it's 80 degrees Fahrenheit, at that point alert will be set to 1, and so all of this will actually then print out at that time. Then we're all going to do an additional if, so a nested if. So if DHT.read temperature true is greater than alert temp. So basically what we're going to do is we're going to set the alert temp. So initially the alert temp isn't set to anything. But here what we're going to do is we're going to set the value of alert temp to equal DHT.read temperature. So whatever the current Fahrenheit value for the temperature sensor is, we're going to make alert temp that value. So what's going to happen is this, as this continues to loop through, basically if the value of the temperature sensor is above whatever the current value of alert temp is, we are going to set the value for alert temp to whatever that currently is. At the same time, what we're going to do is we're going to set the value of alert time. So RTC, this is a real-time clock, and it's going to get whatever the value for the current time is. So basically, if this is above the max temperature, the alert is going to be set to 1. If the value for the temperature reading is above whatever has previously been an alert temp, then alert temp is going to be set to whatever the current value of the temperature sensor is, and alert time is going to be set to whatever the current time is. So that's how that's going to work. Then we're going to go down and we're just going to print out a whole bunch of stuff on the LCD screen. So the first thing with the LCD screen, do not forget the clear function. Do not forget the clear function. So what the clear function does is it clears the entire screen. Remember, when you're dealing with an LCD screen, if you don't clear the screen, if you don't erase what's been printed on the screen, it does not automatically do that. So the first thing that we're going to do in the loop is we're going to delete the screen. We're going to delete everything on the screen, and then we're going to reprint things on the screen so we don't overwrite what we already have. That can be a mess. So then we're going to do set cursor to the first position on the first row. And then what we're going to do here is we're going to get the day of week. So DOW is the day of week. So Monday, Tuesday, Wednesday, Friday, it's going to print out what day of the week it is. We're going to set the cursor to the 11th position on the first row. And then we're going to print out the date. Then what we're going to do is we're going to go down to the 6th position on the second row. This is where we're going to print out the time. So if you notice in the project, the time was centered. So let's go over and just actually take a look at this for a second again. So this is where we have Friday, and then we have date. And then this is where on the 7th position on the second row, so at 6-1. So remember, when you're dealing with the LCD screen, it starts at 0. So the 7th position on the second row is actually 6, and it's 1. So that puts us to the timestamp there. And so we're just putting the timestamp in the middle, just a little user interface type thing going on. Then we're going to go down and we're going to set to the first position on the third row. We are going to print out simply temp, so TEMP. Then at the 6th position on the third row, we're going to print out whatever the Fahrenheit temperature is. At the 12th position on the third row, we're going to print out HUM. And on the 16th position of the third row, we're going to print out whatever the humidity value is. And so that's where we have temp here, then we have whatever the temperature is. We have hum here, and then we have whatever the humidity value is. And so that's actually how we print out everything here. And again, what you'll notice is I rebooted this thing. So basically I plugged this back in. And so since the temperature has not yet gone over 80, then we don't have any kind of alert here, right? That alert will only show up once the temperature value has actually gone above 80. And once it's gone above 80, then it will start printing out the information that we want there. So let's go over and take a look at that while it takes a second to go over. So we're going to go down here is LCD print out alert if max temp is passed. So if alert equals 1, so if alert is equal to 1, the way alert is equal to 1 is if the temperature goes above whatever max temperature you have set up here, right? So if the alert is above 1, set cursor to the first position on the 4th row, print out alert. Then LCD set cursor to the 7th position on the 4th row, and then you're simply going to be printing out what the alert temperature is, so whatever the value is that we set here, that's what we're going to be doing. And then when we come down here, we're going to do set the cursor to the 13th position on the 4th row, and then after that, we are then going to print out the alert time. So we set the time here, getting from the real-time clock, whatever the time string is, that value, again, that's all set up in this if statement, and then that's going to get printed out on the screen. So if we go over and we take a look, now that I've heated up the temperature sensor, again, we can now see that it says alert. It says it got up to 87.98 degrees, and it got up to that time, that temperature at this specific time. And so that's what you do. And so again, remember with this project, you can turn the backlight on. So again, this is with the backlight on. The problem is for most of these projects, why I don't turn the backlight on is it can be difficult for the camera to see what's going on. But that's basically how this project works and how the code works. So yay! You're now learning how to use, multiple different, modules and sensor type things to actually create your Arduino projects. Again, the important thing to remember whenever you're creating your Arduino project is that you can build whatever you want. Again, I'm showing you how the nested if statements work. I'm showing you how you can pull information from a real-time clock and from a temperature sensor and print it out to the LCD screen. What you decide to do for your particular project, that's up to you. Again, you take this information, you copy and paste the hell out of it, and you create, whatever kind of project that you want to create. But I just wanted to start showing you again how we can start adding all of these different little components to your Arduino device to create nifty, neat little projects. Again, with this type of thing, you can add additional stuff to it. So one of the things we're going to do in the future is we're going to start adding this. So basically what this is this is an IoT relay. So you can plug your Arduino directly into this, and essentially it's a power switch. So you can have your Arduino trigger electrical devices to turn on. So again, let's imagine if this is the real world, I'm putting this into a production environment, not only do I want an alert to trigger, not only do I want to know that the temperature hit a certain value, but again, if the temperature in my server room goes above a certain value, maybe I also want to turn a blower fan on. So for a project, what I might do is not only if the temperature is above a certain amount, print out an alert on the screen, but I might also want to send a signal to like an IoT relay to then turn on some kind of HVAC system to try to cool down the environment, right? So this is the type of thing to start thinking about with the Arduino. It's very easy to look at these Arduino projects and think of like one sensor and one display device and how they work together. What I want you to start thinking about again is how you can start connecting multiple different components to your Arduino project to actually make something useful in the real world. I think one of the big drawbacks with Arduino is in many ways it's so easy to use that a lot of people don't think it's like real tech. Like, oh, it's nice. I'll play around with an Arduino, but then I'll go and I'll deal with real technology with Linux or something like that. What I want to start showing you, though, is that this is a way that you can actually build systems for the real world relatively easily that can actually do things. Again, HVAC, kind of environmental controls, gardening controls. There's all kinds of stuff. Everything from being able to determine if network devices or websites are up, to what the temperature is, to other types of things. There are so many things that you can have the Arduino do. That's pretty nifty neat. Again, if you start adding everything together. So anyways, there you go. As always, I enjoyed doing this class and look forward to seeing you in the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.